You guys, this is a big day. This is our last lesson for the quadratic unit. So, good things are coming to an end here. Today we're going to talk about the types of problems that you're going to see in the future where I give you a quadratic, I ask you to solve it, and I tell you that you can choose whatever method you want. Okay, so we're going to analyze kind of how you go about that problem and how you pick the easiest, most efficient method for the quadratic that you're looking at. So we're going to review all 5 methods for solving and then look at when it's most appropriate or maybe when it's least appropriate to use each method. So this is a review lesson and kind of applying all these methods to certain quadratics. Okay, so pay close attention. Method number 1 for solving a quadratic. Ooh, and before I kind of go in and say each method, I want to point out one thing here. When you're solving for x in something that has an x squared, remember there are 4 different names for the answers. They can say find the solutions, find the x-intercepts, find the roots, or find the zeros. Those all mean the same thing. Don't let any of those terms weird you out. Okay, the first method we learned for solving for x when you've got an x squared was graphing. Now, you should only use graphing if I tell you to solve it by graphing. It takes a long time, and it's not a very good method because you can only see the answers if the parabola nicely crosses the x-axis. Okay, if the parabola doesn't cross the x-axis at a nice clear point, you're never going to be able to tell the answers. You will have to solve by graphing, with that being said, but I will tell you to do that. So let's remind ourselves how you do that, because I think a lot of us forget the process. So the first process would be to tell me what A, B, and C are. Kind of ignore the equals 0. The y is gone and it equals 0. That just means you're solving it. So A would be 1, B would be 0 on this one, and C is -1. The second step is to find the axis of symmetry. So that's the line x equals, and then you do the formula -b over 2a. So for this example, that'd be 0 over 2 times 1, which would just be 0. Okay, so x equals 0, that line is where the parabola gets cut in half. Then you would find the vertex. Once you have the axis of symmetry, that's the x value of the vertex. You plug that in for x here to find the y value that goes with it. So when I plug in 0 right here for x, I just get -1. Okay, so that's my vertex, and then I make a table. And remember, we put our vertex in the middle. Ooh, I did not leave much space there for myself, but that's a -1. Then we did 2 numbers smaller, 2 numbers bigger. Okay, one at a time, I'm going to plug them in for x. Do not forget to use the parentheses. When I plug in -1, I get 0. That should be the same thing when I plug in +1. And then for the 2's, I get 3. So I plot my points, get my u on my graph. And then again, I look where it crosses the x-axis, and those are my solutions. So this is a good problem because it crosses pretty nicely at -1 and +1. Perfect. I want to make a note up here that you can always check your answers when you're solving. Okay, do not forget that come exam time. If you've got time at the end and you're on the solving part of the exam, you should check your answers. I should plug in -1 and +1 in for x, and I should make sure that it actually does equal 0. And it does. Okay, so that's method number 1. Method number 2 was solving by square roots. Okay, you should use this method when b equals 0. This problem would have been way faster and way easier if I would have done the square root method. B was 0. Realize that this method can't be used if b does not equal 0. So if you have a b value in there, like this example right here, I have that -20x in the middle. If that's there, you cannot use square roots. But if it's not there, square roots is the method to pick because it's the easiest, it's the quickest. I will say do not forget the plus or minus sign when you take the square root of both sides. That's the most common mistake. So if I see the b value is not there, I'm just going to get x squared by itself. And I'm going to make that note. This is going to be a really good reference sheet for you guys to have because I'm kind of making a note on every method, how you go about solving it. When I'm running out of room here. Carried over to this line here, sorry. Square root both sides to get rid of the x squared, and here's where you got to put that plus or minus sign. The answer would be plus or minus 10. If I had time, I would check my answers. I'd plug in 10, I'd plug in negative 10, and I would have it. Okay, so that's square roots. Method number 3 was completing the square. This method is best when the b value is even and when it's relatively large. This method kind of is easy to work with in that case when the others maybe wouldn't be. Do not use this method when the b value is odd. Okay, don't even go there. If you see a problem where the b value is 5, do not even consider completing the square. You'd have to work with decimals, and none of us want to do that. Okay, so when b value is even, also it should only be used when a is 1. So if I see something like here, where the a value is 5 or 6, don't even consider completing the square. Okay, but this example would be one that would be good because the a value is 1, the b value is even. So here's how you do completing the square, just to remind you. You need to make this trinomial a perfect square trinomial. And this one's not because 21 is not a perfect square number. So you have to get that out of there. Leave a space because you're going to make this a perfect square. So I'm going to add a number onto both sides that makes this a perfect square trinomial. To do that, remember we thought to ourselves, what number added to itself is negative 20? And that's negative 10. Once I find the number, I multiply that number by itself. So I'm going to do negative 10 times negative 10. That's the number that I'm going to add here that makes this a perfect square trinomial. Whatever I add to one side, I have to add that same number to the other side. Okay, I can factor this now into x and x, and it'd be negative 10 and negative 10. Okay, so this factors nicely. If it's the same factor, which in completing the square it always is, remember we just went straight to writing it as x minus 10 squared, and that would equal 121. Then you just square root both sides. Do not forget the plus or minus. I'm running out of room here, so plus or minus 11, square root of 121. And then you write two equations. X minus 10 can equal positive 11. X minus 10 can equal negative 11. And then I just solve both equations. So I'm going to add 10 in both of them to get my two answers. And one of them is x is 21, and the other one is x is negative 1. Again, if time allowed, I should plug in 21 and negative 1 one at a time and make sure that it actually equals 0. Method number 4 was factoring. Okay, so let's kind of jot down some notes on when factoring would be good to use. This method should be used when you are able to find the factors. So if you can't find the factors, and I'll show you what I mean by that, then you should just move on quickly and use a different method. So here's what I'm going to look at, and I'm going to also make another note. Use this method when a equals 1. Unless I force you to use this method on the exam when a is not 1, if you're given the choice and you see that a is not 1, like number 1 down here, if I see that it's a 5, throw factoring out the window right away. Don't even consider it. Okay? I see that a is 1, so I'm going to try to find the two factors. Here's what I mean by that. You're looking for two numbers that multiply to be the c value, 12, and add to be the b value, negative 7. And it jumped out at me pretty quick. I see that it's -4 and -3. Those multiply to be 12 and add to be -7. So I'm just going to factor this and rewrite it. And then I use the zero product property to write my two equations. And when I solve those, I get my two answers. Okay, so that was pretty easy if I remember factoring. And then lastly, we learned the quadratic formula, which I'm reminding you what it looks like right here. Remember, you don't have to memorize it. This method should be used whenever A is not 1. Okay, honestly, if I give you the choice and I let you use whatever method you want and A is not 1, you're going to go straight to the quadratic formula. One exception to that, unless B is 0, then you want to use square roots. Okay, anytime the B value is missing, use square roots when you get the choice. Okay, this method should also be used whenever the other methods don't work. Okay, because remember that there's never a time when this method doesn't work. It works for any of these quadratics. So worst case scenario, if I give you the choice and you can't figure out another method, resort to quadratic formula because it's going to work every time. Factoring doesn't always work because you can't always find two numbers. Maybe the answer is a decimal. You're never going to be able to pick that out. Okay, so last resort, go to quadratic formula. But also I want to point out that I wouldn't jump straight to it right away because it is one of the most time consuming. So you might run into time issues on an exam if you pick it every time. And it does have the biggest chance for mistakes. There's a lot of places to mess up. So try to find another method to use for the problem if you can. Okay, I'm not going to do an example of quadratic formula. We're like fresh off of that. Hopefully that's pretty clear in your mind how to do that. We'll practice later though. Okay, so for these 6 examples, I'm not actually solving them. It just says pick which method you would choose to solve and explain why you chose that method. Okay, so let's think through a few of these. Number 1, here's what would jump out at me right away. I would see that A is not 1. Okay, I'm definitely not going to use factoring. A is not 1. Graphing, no way, because I'm not going to pick graphing no matter what on any of these. I can't do square roots because B doesn't equal 0. Honestly, right away, I would see A is not 1, and I see that there's a B there, so I'm going to go straight for quadratic formula. If I did factoring, I would have to do guess and check, and I might not even be able to figure it out by guessing and checking. It might not be factorable. So jump straight for quadratic formula. Main reason, A is not 1, and there's a B value there. Okay, and I know quadratic formula, it's going to work for me every time. On number 2, I would look at this. I would see that the B value is there. It's 5, so I can't use square roots. I'm not going to do completing the square because the B value is odd, so I might try to factor it, and I might just see if I can find the numbers real quick. If I can't, I'd move on. So let me see. They have to multiply to be -14 and add to be 5. Ooh, that's going to be there. +7 minus 2. So that was pretty quick. The two answers are -7 and +2. So I'm going to factor it. Why did I choose this? Well, it was easily factorable. And because A was 1. Those are the biggest reasons I jumped to that. For number 3, okay, here's an example where you shouldn't just say, oh, quadratic formula. Don't do that because, look, the B value is missing. When the B value is missing, square roots all day long. All I'd have to do is add 24, divide by 6, and square root, and I'm done. Okay, pick out that method really easily. It will save you so much time. For number 4, okay, I would see that there's a -407. Yuck, that's not a nice number to work with. I'm not going to try to factor that. I don't want to think about factors of 407. Not good. I can't do square roots because there's a B value. I'm not going to jump to quadratic formula right away. Graphing's not even an option. Completing the square, this would be a good method to use on this one. And I see that the B value is even, so I'm going to go for that. And the reason I picked this is because b is even and a equals 1. Those were kind of the two things we said to look for. B is even, and we've got relatively large numbers. Completing the square is pretty good to use, and a is 1. So I'd just add the 407 over, then I'd find the number that I need to complete the square, rewrite it. That wouldn't be too bad. Okay, I want you guys to tell me, and maybe there's not necessarily a right answer. I might ask you to like back it up when I come around to check your notes tomorrow. But tell me what method you would choose for 5 and 6 and give a little explanation why.